I'm Randy Nesse from the ASU Center for Evolution and Medicine, and today my special guest is Lee Dugatkin, who I've known for many years, and we have several interesting topics to cover. First of all, tell us a little bit about where you're from, Lee, and what you do.
I'm an evolutionary behavioral biologist, so I'm basically interested in how social behavior evolves both in humans and non-humans. Right now I'm at the University of Louisville. Been there for a while, grew up in Manhattan, and I'm all over the place, including wonderful places like ASU.
And you write a book almost every year, and the rest of us wonder how you do it. You're also the author of a wonderful new evolutionary biology textbook.
I love to write, and the beautiful thing about being an evolutionary biologist is that there are endless, fascinating, interesting topics to write about, and so I've been fortunate to have the time and the resources to do it, and I love it.
So one of the biggest ones
Right.
that you and I have both been preoccupied by for several decades now, along with a few thousand other scientists,
Exactly.
is the mystery of altruism.
Right.
But why is altruism a mystery? I thought people were generally just pretty nice.
Well, so if in fact people are pretty nice, the question then for an evolutionary biologist is why in the world should that be? And that's where the mystery comes in. So for an evolutionary biologist, we want to know how natural selection might favor this kind of nice behavior that we're talking about. We want to use basic ideas that have been developed since Darwin in evolutionary biology to sort of do a kind of cost-benefit perspective. What are the costs of being nice? What are the benefits of being nice? And the mystery is that, generally when we think about the way that organisms interact with each other, including humans, we, as evolutionary biologists, we tend to think that anything that makes somebody better at getting stuff, and stuff could be food, it could be mates, it could be someplace safe, anything that makes you better at getting that than others, that's going to be favored because it's going to allow you to either survive longer, maybe get more mates, produce more offspring. But generally, when we're talking about the sorts of things we're talking about, evolutionary biologists will often call this altruism, and we just mean something that's costly to you and helps others. Pretty close to what we mean by being a good person. You're willing to do things even if it's costly to you to help others.
So a lot of people assume that a group composed of all selfish individuals wouldn't do very well, so therefore natural selection makes people more generous and the like.
That's certainly something that you'll hear often, and one of the things that evolutionary biologists have done in this sort of modern round of thinking about behavior and evolution is show how that logic tends to fall apart. And what I mean is that basically what we need to do is think about it at the level of the individual. What are the costs and benefits associated with being nice, not whether or not the group is full of nice individuals. That might have an effect on you, but the group itself and how many nice or non-nice individuals are in there is not the focus of the way that evolutionary biologists think about this problem, or most of them.
So
anyway.
some people seem to conclude from this that natural selection inevitably creates individuals who are selfish.
This is not a new thought. Ever since the whole evolutionary framework has been put in place, people have been making this sort of argument that we should just end up with selfish care individuals who have no care for anyone else because that'll get you the most things. But in fact, it turns out that that's wrong in the sense that there are certain circumstances in which working with others to solve a problem is better for you than not doing that. And
So what's an example of that?
Oh, in everyday life, or even just sort of in what you might hear about, everything from solving a problem of defense. So let's say you want to figure out how to make your community or your neighborhood or your block safer. Well, there's some things you can do by yourself, but on the other hand, there are certain things that it's going to require some sort of coordination or cooperation among you and others in your neighborhood to do that. Now, it's true that you have to interact with others and you're part of a group, but from your perspective, you're much more likely to be safe as a function of having others work with you to do that.
Nice. Is this old stuff, or has evolutionary thinking really changed how we understand cooperation in relatively recent decades?
Yeah, it has changed, and in fact, that has been one of the central ways that the modern area of evolution and behavior has come to fruition in a sense over the last 3 or 4 decades. In particular, we have I wouldn't say completely solved, but we've really got a pretty good handle nowadays on what are the ways that you can get goodness and cooperation.
Can you just list the ways? How
Sure,
many
sure.
different ways can you get an advantage by being generous?
Sure. There's a couple that are classics, and there are a couple that are more contentious. So the classic ones would be that if you help your genetic relatives, if you help your family members, but not family in the everyday definition, but family in the sense of you are related to them genetically. Share genes, your offspring, your siblings, your parents, not your spouses, not your in-laws. That's the difference between the two definitions, right? And the idea here is that by helping those individuals, what you're doing is indirectly helping copies of the genes that reside in your body. It just so happens they're residing in another body, which is the body of your relative. And that's what makes them your relative.
So genes identical to you are in your relatives. So some people have said this might have something to do with people living after they can't reproduce anymore, because they can actually do things to help their own genes.
Right. So that there are a number of ideas on this, sort of a grandmother hypothesis and along those lines. And there the notion is that even though you in fact cannot reproduce, particularly for females after a certain age, there's plenty of things that you can do to promote this, the survival and success of both your offspring and your other genetic relatives. Besides, pumping out new babies, you can be doing things that help your children secure a good life, secure a mate, produce children, live a good life. There's plenty, but there's all sorts of other ways. It doesn't have to be anything as direct as your children. If you help your siblings, if you help your cousins, you also are helping individuals who have copies of the same genes you do. Now,
so is there a name for this?
Yeah, it's called kin selection is the general term we use for this, and it's basically arguing that selection can favor this kind of behavior because you help your kin.
So where did this idea come from?
It's been around in sort of an informal way for a long time, but it became formalized and really took hold in the sciences back in the early 1960s, when a brilliant evolutionary biologist by the name of W.D. Hamilton, during his graduate work in the UK, formalized this, meaning that he actually came up with a mathematical way to represent how this kinship that we're talking about can favor goodness.
So are the mathematics really complicated?
Well, they can be, but they need not be. So you can produce a very, very complicated version of it, but in fact, you can make it extremely simple, the sort of thing that truly someone who has taken 9th grade algebra can understand. And that is something that, that's one of the reasons that we tend to think of Hamilton as one of the greatest evolutionary biologists of the century, was that he could take this quite complicated idea and boil it down to something that anybody who's had algebra, and probably even people who haven't, could understand.
So tell us the formula.
So the formula, which by the way goes by the name of Hamilton's rule, is that if you want to know whether or not goodness, altruism, will evolve via this kinship route we're talking about.
So whether a gene that makes individuals do things that are better for others than themselves, is that really what we're talking about?
Yes, it is what we're talking about. A gene, or perhaps a common
allele,
or even perhaps a couple of alleles that are working together, but that's the general gist of it. That will be favored if the genetic relatedness between individuals. So if you're cousins, if you're siblings, we have a way to measure that numerically.
So what percentage of genes do we share with our siblings and with our cousins?
That's right. So for example, we share 50% of our genes with our siblings. We share 12.5%, an eighth of our genes with our cousins. We share half of our genes with our parents. And we have this table, essentially, that you can get that number for any combination of genetic relatives. If you take that number and you multiply it by how much you're helping the individual you're helping, your kin, and if that, when you multiply those two things, if that's bigger than the cost that you have to pay to help, then we expect this goodness to evolve. And essentially what's happening is you're getting this indirect kickback. So you're taking the benefit that others get and you're getting some of that back. How we measure how much you're getting back is by how related you are to them, because that's how likely you are to have the same gene.
So if it's a very close relative, then if the cost is anything smaller than half the benefit, it's a go.
That's right.
Well, if it's your cousin,
right,
the cost has to be less than an eighth.
That's right, if it's one cousin, but in fact it gets kind of interesting because there are lots of things that you can do in which you help many of your relatives at one time, and that makes altruism easier to evolve. So imagine that you take some risk to warn your relatives that that a tiger is on the periphery of where you live, or that a warring party is coming. If you can give that alarm to one individual who's your relative, that's great. You get that sort of benefit that we've been talking about. But if you can help 8 of your relatives at one time by doing the same thing, then it's much easier.
Big time benefits.
Big time benefits, which means this behavior evolves more easily.
So kin selection is one explanation.
That's right.
What's another one?
Another classic is reciprocity, and there we mean you basically exchange acts of goodness. So
it's trading favors.
Trading favors. Basically, the idea is that it's worth the cost to you of helping somebody else if there is a high chance that when you need help later on, they'll be there to help you. If that probability is great enough, then it's worth helping them when they need it because it's an insurance policy.
So in reciprocity, there's always a chance of cheating because things are delayed. But aren't there a lot of cases where people do things to help others and it's necessary to get help? I mean, there's a real mutualism.
That's another path by which you can get the evolution of altruism, or goodness, let's say. This notion that when you do things together, cooperatively, you both benefit from that kind of the result of that. And in all likelihood, that's extremely common. And it's not only common among within humans or in animals, it's also common between species.
What's an example between species?
Oh, it might be something like you look at certain ant species in Africa and the acacia trees that they live on. So the acacia trees have this problem where there are lots of nasty insects that are doing damage to the acacia trees. And one way they get around that problem is they basically hire ants that will keep them safe from all the other nasty critters.
How do you hire an ant?
You hire an ant by offering them a nice bit of sugary liquid.
How do you make sure they do their job in return for that pay?
Well, if they don't do their job, you can do things like curtail the amount of sugary liquid that you produce. Not necessarily immediately, but over periods of time. Mm-hmm. And it's sort of interesting if you think about this kind of mutualism where everybody gains. It's even strange and paradoxical that in many ways evolutionary biologists have not paid much attention to this. And the reason is that we tend to be drawn towards riddles and paradoxes more than other things. And this is sort of pretty basic, right? If I do something and you do something and we both get a benefit for it, there's no mystery.
We both turn over a rock together to get the grubs underneath.
There's no mystery as to why that will evolve. It's only when I do something for you right now that's really dangerous for me, and you do something later where there's this chance you might not do it and you might do it, that we have to sort of figure out how that works. So that's where we end up spending most of our time. And there are one or two other paths that have been discussed for the evolution of cooperation and altruism as well.
So for those of us who are humans, and most watchers of this tape I think will be humans,
probably,
we're really interested in guilt and morality and not just trading favors, but actual goodness. Do you think that actually exists? And if so, how could it come about?
Yes, I think it exists. But it sort of depends on at what level you're asking the question. So I think that people generally have a tendency to be good towards one another. I think that that's the result of natural selection. One problem I would say with being an evolutionary biologist who likes to talk about this is that at the end of the day, I think you could always make the case that whatever kind of altruism, goodness, niceness we're talking about, any evolutionary explanation sort of takes the goodness and niceness out of it, in the sense that one way or another, what we're going to do with our evolutionary approach is show how either directly or very, very indirectly, you yourself are going to be compensated.
Or your genes.
Or your genes, right. And you are your genes to a large extent. Okay.
That,
well, you are your genes.
Your behavior
manifest in a particular environment that's been under various pressures for long periods of time, right? I don't mean to make it sound as if it's all predetermined and you're going to do this.
Feel like goodness isn't really possible because everything fundamentally is selfish, but is there some way out of this dilemma?
Well, yes, there's a way out of a dilemma, but it's also not as much of a dilemma as that makes it sound like, because really we don't really care whether or not individuals themselves, one way or another, get something out of it as much as we care whether or not we're living in a society where people are good to one another and doing nice things. And so one way that happens is the sort of things you were talking about. We have developed a psyche that over time has been shaped by these evolutionary forces that we're talking about in a way to make you feel bad when you haven't helped somebody who needs help. Why might you feel bad if you don't help someone who needs help? Well, it might be that others are going to look at you in a very disparaging way. They're going to see somebody who is not trustworthy, who is not someone they want to interact with. That has all kinds of consequences to you. Your reputation is very important. People want to be able to trust that if they need you when there's something nasty that's going on, or even when there's something good that's going on, that you will be there. And so we have evolved a psyche that is very, very conscious of what other people think of what we're doing, because that produces behavior this kind of good behavior that we've discussed indirectly or directly can help you as well.
So would this be characterized fairly as a revolution in how we understand cooperation in organisms in general?
Oh, I think it absolutely. I mean, I think it's sort of the fundamental problem that the people who study behavior and evolution have been dealing with for 100 years, and we really do now have a pretty good handle on that. And it's not just that evolutionary biologists should care, because the kind of things we're talking about here, these are things that psychologists and psychiatrists and sociologists and anthropologists and economists and everybody who's walking around on the streets who has to deal with all of these situations every day, constantly, about who should you be nice to, who should you trust, who's going to trust you, who should you give some of your money to, who should you not give your money to. All of these things are sort of constantly problems we have to deal with. And the bottom line is that evolutionary thinking has reshaped the way that we understand this.
And this is what we talk to each other about over drinks and over dinner and parties, as we want to know about other people and what they're really like.
That's right.
That's wonderful and so important.